Hi guys! Are you ready to learn? Tara at pag-usapan natin ang isa sa mga mahalagang bagay or topics that we need to know about the plumbing system. So in this video, we will tackle about the sanitary drainage system, its essential components, why is it important, and how it works. May idea ka na ba tungkol dito? If meron na, that's good! At kung wala pa, watch this video till the end for you to learn. To start our discussion, we will first talk about wastewater, which is what we manage in the sanitary drainage system. So, ano nga ba itong wastewater? Wastewater, sometimes referred to as sewage, is used water. It comes from almost all sections of the building, including the bathrooms, kitchen, and laundry areas, and in commercial projects, equipment being serviced. So, simple as that, ito yung gamit ng tubig. We will now proceed to the conventional sanitary and drainage system. A sanitary drainage and vent system, sometimes referred to as the DWV, or the Drain, Waste, and Vent System. It is a network of pipes that remove wastewater from a building. In typical plumbing system operations, the sanitary drainage side of the system consists of traps at each fixture and fixture branch, stack, and drain pipes. So, these are the essential components of our sanitary drainage system that we will later on discuss in this video. These components carry wastewater away from the plumbing fixtures and out of the building. Water transports waste into the sanitary drainage piping and out of the building sewer line, leading to a community wastewater treatment plant or to a private sewage treatment system. Dagdag kaalaman, alam mo ba na ang sanitary drainage system is also known as gravity system? This is because gravity is a driving force behind wastewater flow. So sometimes, our wastewater has some residue or solid matter. This can be a problem to pump out the wastewater together with the residue. Aside from the wastewater, we also need to manage the foul gases or foul smell brought about the wastewater. Kaya meron tayong tinatawag na vent system. The vent system side of the system introduces and circulates air in the system to maintain atmospheric pressure in the drain lines and ensure adequate gravity flow of wastewater. Ang vent natin, ito yung nag-prevent ng negative pressure or suction sa ating system. Dahil kapag nagkaroon ng suction, it could suck water from fixture traps and i-allow nito ang sewer gases na mag-infiltrate sa building. The vent system also exhausts sewer gases to the outdoors. It allows the sewer and drain system to flow freely. They do so by allowing air to flow into the drain system, thereby equalizing the pressure within the pipes. Let us now proceed to the essential components of sanitary drainage system. So first, we have traps. A trap is a U-shaped pipe that catches and holds a small quantity of wastewater that is poured down a fixture drain. The trapped water prevents gases resulting from wastewater decomposition from entering the building through the drain pipes and the fixture. Traps can be made of copper, plastic, steel, wrought iron, or brass, with plastic most commonly used. We have different types of traps that are classified based upon their shapes. First is P-trap. P-traps exit into the wall behind the sink. The traps are made from UPVC or cast iron sheets. This trap also has a water seal and prevents entry of foul gases to the house. Among all the types of traps, this is the most acceptable type of trap. As you can see here in the picture, we have a lavatory with P-trap. So kapag humuhugas tayo ng kamay mula sa tubig na nanggagaling dun sa faucet, ito ay dumediretso sa ating P-trap. At dahil mababa ang posisyon ng P-trap, meron itong negative elevation. Kaya naman, nai-stuck doon ang tubig. Ang stock water nito ay mayroong purpose. And the purpose of it is to create a water seal so that gases will not enter from the wastewater. So, since the water seal prevents the entry of gases, air will not penetrate in the water. Kaya hindi makakasingaw yung mabahong amoy na nagmumula sa tubig. At para ma-preserve itong water seal, meron ditong nakakabit na vent which will be discussed also later in this video. Aside from P-trap, we also have Q-trap. This trap is used in toilet under water closet. It is almost similar to the S-trap and is used in the upper story other than the ground floor. We also have S-trap. This trap is usually used with siphonage pipe. It is similar to the P-trap and is used for fixing water closets in toilets. The only difference between the P-trap and the S-trap is that the P-trap is used for an outlet through the wall, whereas S-trap is used for an outlet through the floor. However, these two types of traps, the Q-trap and the S-trap, can easily be siphonaged, so they are prohibited by the building code. We have other types of traps based on use: floor traps or nanny traps, running trap, galley traps, straight-through trap, intercepting traps, low-level bat trap, bottle trap, bell trap, grease trap, building trap, and drum trap.
Number 2. Interceptors. Many substances like grease, faucet, oil, hair, sand, clay, wax, or debris are accidentally or intentionally placed into a building drain, potentially creating blockages that can cause backups and overflows or contaminating wastewater, which makes treatment difficult and more costly. Interceptors are passive devices designed into a plumbing system that trap, separate, and retain these toxic or undesirable substances from wastewater before it is discharged into the sewer line. Typically, interceptors are sized for at least a 30-minute peak wastewater flow detention time from all contributory sources. A grease interceptor for a restaurant can have a capacity of 1,000 gallons or 3,800 liters or more. Interceptors should be located as close to the discharging fixture as possible. They sometimes also serve as the trap, with some exceptions. Grease traps must be located at least 10 feet or 3 meters from hot water faucets. All hot water must cool to 120 degrees Fahrenheit before entering the grease trap. Number 3. Fixture branches. Each plumbing fixture is connected horizontally to the sanitary drainage system by a drain line called a fixture branch. Branch piping, which serves urinals, water closets, showers, or tubs, is usually run under the floor. When these fixtures are not on the branch, the piping may run in the floor or in the wall behind the fixtures. Branch piping may be copper, approved plastic, galvanized steel, or cast iron. Number 4. Stacks. The fixture branches feed into a vertical pipe referred to as a stack. We have two kinds of stack: soil stack and waste stack. The first one is soil stack. It is when the wastewater that the stack will carry includes human waste from water closets, or from fixtures that have similar functions. While waste stocks is when the stock will carry all waste except human waste. Soil and waste stocks may be copper, plastic, galvanized steel, or cast iron. These stocks service the fixture branches beginning at the top branch and go vertically downward to the building drain. So the diagram shows how the stocks work from the stock vent through roof downward or vertically to the house drain or building drain.
Building drain. The building drain is the soil or waste stocks feed into a main horizontal pipe. By definition, the building drain extends to a point 2 to 5 feet or 0.6 to 1.5 meter outside the foundation wall of the building. The building drain slopes 1/16 to 1/2 in per foot or 5.2 to 41.6 mm per meter as it feeds the wastewater into the building sewer outside the building. Slopes 1/8 to 1/4 in per foot or 0.4 to 20.8 mm per meter are common in most buildings. Building sewer. The building sewer is an extension of the building drain that carries wastewater from the building drain to a community sanitary sewer main or an individual on-site sewage treatment system. In community sanitary waste systems, the building sewer may also be known as a house or building connection or sanitary sewer lateral.
Another component of a sanitary drainage system is the sanitary sewer main. It is a pipe through which the wastewater flows as it is conveyed from a building to the wastewater treatment plant. Typically, the minimum size of a community sanitary sewer main for a gravity-based system should be 8 inches in diameter. Another is the cleanouts. There are two types of cleanouts, the floor and wall cleanouts. Floor cleanouts are found in horizontally positioned building drained or sewer lines that are installed in the floor or in the ground. Wall cleanouts are placed in vertically positioned stocks. All cleanouts in vertical stock should be located no higher than 48 inches above the floor. Cleanouts are generally required at the base of soil and waste stocks, at the upper end of building drains, at each change of direction of the horizontal building drainage system greater than 60 degrees. The total of the fittings between cleanouts shall not exceed 120 degrees, and that the junction between the building drain and building sewer usually 2 to 4 feet away from the building.
Another component of sanitary drainage system which has an important contribution on it is venting. So let me first define to you what vents are. These are pipes that allow enough amount of air into the drainage system which help in reducing air turbulence from siphoning or back pressure. Also in releasing sewer gases outside the system. Vent piping may be copper, plastic, cast iron, or steel. So guys, importante ang venting like what I've said because it protects the trap seal as its main function. For you to understand it better, let me give you an example on how it works. So as you can see here at the right side of the picture, may vent tayong makikita. Whenever there's a negative pressure na manggagaling dito sa baba, what vents do is to give passage for the gases so that hindi na to babalik papunta sa trap at hindi masisira ang trap seal. Dahil dyan, mape-prevent ang pag-cause ng mabahong amoy na lalabas dito sa lavatory. Now, let's go to the types of venting methods. First is individual vents. Individual venting is a method of installing a vent pipe for every trap or trap fixture. It is the easiest among the methods but medyo costly siya because of the number of pipes required here. Okay, from this image, you can see that there's an individual vent for this water closet and another individual vent for this one. So this is what individual vents are. The second method is the common vents. This one is less expensive than the former because common venting method serves two fixtures located on the same floor. Yes, you heard it right. This is only applicable para sa dalawang fixtures lang. Like from this example, may dalawa tayong lavatory dito. Here and here. These are both connected to the same vent na makikita natin dito between these walls. So this is what common vent looks like. Next is the wet vents. This method provides one vent pipe connected to all trap or trapped fixtures of one or two bathroom, which are located on the same floor. So to visualize again, here is an image. You can see here the wet vent. So connected siya sa basin at the same time sa toilet. So guys, this picture shows only two fixtures. But if a bathroom has more than that, pwede pa rin i-apply ang wet venting. Basta for all fixtures siya. So, to differentiate these first three methods, just remember this. For individual venting, one fixture, one vent. For common venting, two fixtures, one vent. And for wet venting, all fixtures, one vent. Next is the circuit vents. In this method, a horizontal venting pipe will serve up to 8 fixtures, and each one should be connected to a single horizontal drain. So guys, dito, vertical drops are not permitted. The last method is combination drain and vent. This one helps the distance from trap to vent to be extended infinitely. Here, drain is in horizontal orientation and a vent somewhere is connected with the horizontal branch. So this picture shows how combination and vent method works. Before I end this part, there is another information you need to know. Mayroon tayong tinatawag na vent stack, and it is important in a plumbing system of a building because this is where air flows from the outside, since it extends vertically and up through the roof of a particular building. So this vent stack must be extended beyond the roof for at least 6 inches or 152 millimeters.
The next discussion is about different ways so that the need for venting is eliminated. One of those is the air admittance valve. Air admittance valve, or AAV, is a pressure-activated, one-way mechanical venting port used to eliminate the need for expensive venting and roof penetration. Wastewater discharge causes the AAV to open, allowing air to circulate in the vent system. When there is no discharge, the valve remains closed, preventing the escape of sewer gas and maintaining the trap seal. So ang kailangan natin is to provide a passive pressure para hindi may stuck ng tubig sa P-trap at hindi siya dumiretso sa drain. So using air admittance valve, we provide a positive pressure so that the water from the P-trap remains, so the water seal can preserve. Positive air pressure attenuator. Positive air pressure attenuator is a product developed to protect buildings of 10 or more stories against unwanted positive pressure. Example of back pressure generated in the DWB system. PAPA are installed at the base of the soil, in waste stack, and at various floor intervals depending on the height of the building. A PAPA/AAB system counters the tendency for the loss of trapped water seals resulting from positive pressure faults in the soil in a waste stack. It may be used in sanitary plumbing system as an alternative to relief venting, eliminating the need for a continuous parallel relief venting pipe. Sewage ejection. For the most part, sanitary drainage system rely on the force of gravity to create flow to discharge wastewater. In some building installations, however, a fixtures or group of fixtures has to be installed below the level of the available sewer line. In this case, wastewater must be lifted to the level of the main drain or sewer by a pumping system called sewage ejector. This is needed when our fixtures, example ay toilet, ay mas mababa kaysa sa sewer. Kunwari ay kung meron kang CR sa basement. Hindi dadaloy ang wastewater papuntang sewer na nagagaling sa toilet dahil mas mababa ang toilet. So, kailangan mo ng sewage ejector. Typically, a sewage ejector can pump solid from 2 to 4 inches in size or grind solid waste before passing them through the ejector. A sewage ejector system consists of sump basin, a motor pump assembly, and a system of automatic electrical controls.
So for our last topic para sa sanitary drainage system, we have the drain and vent pipe design. Bago natin simulan yung discussion dito, nais ko lang linawin na kung sa water supply system, yung unit na ginagamit nila is WSFU. Sa drainage naman, yung unit na ginagamit natin dito ay DFU or the drainage fixture units. So ano nga ba yung drainage fixture units? The draining rate for plumbing fixtures is based upon the drainage fixture unit or DFU. The DFU is an arbitrarily, so pag sinabi natin arbitrarily is by chance or nagkataon, arbitrarily chosen measure that allows all of types of plumbing fixtures to be expressed in common terms. That is a fixture having twice the instantaneous drainage flow rate of a second fixture would have a fixture unit value twice as large. The WSFU and DFU may differ slightly for a single fixture because the rates of filling and draining are different. So, para mas maintindihan kung ano nga yung DFU natin, I have here a 4 table. We have the table 14.1 or the drainage fixture units and minimum trap size for selected plumbing fixtures. So, sa table na to, makukuha natin yung katumbas na DFU ng ating fixtures. Sa next table is the table 14.2 or the maximum drainage fixture units that may be connected to horizontal fixture branch and stack based on pipe size. So, sa table naman to is makukuha natin yung diameter ng ating horizontal fixture branch and stack gamit yung nakuha nating DFU. Sa third table or the table 14.3, we have the maximum drainage fixture units that may be connected to a building drain or building sewer based on pipe size when the building drain and sewer serves one building. So, dito naman natin makuha yung para sa building drain or building sewer. And lastly, sa table 14.4a, we have the required vent diameter and maximum length of vent based on soil and waste stack size and connected drainage fixture units or DFU. So, sa table na to, makuha natin yung diameter ng pipe ng ating vent. So, para mas clear sa atin, magbibigay ako ng example. So, itong example. The following number and type of plumbing fixtures serve 2 apartment units, 2 bathtubs, 2 water closets, 2 lavatories, and 2 kitchen sinks. Assume the horizontal fixture branch serving these fixtures flows into the waste stack. Assume the vent stack extends through the roof and is 22 feet long. Determine the minimum pipe diameter required for the horizontal fixture branch, waste stack, and vent stack. So, klaruhin ko lang muna yung problem natin. So, meron daw tayong 4 na fixture, yung bathtub, water closet, lavatories, and kitchen sink. Tapos, yung horizontal fixture branch daw natin ay dumadaloy papunta sa waste stack. So, galing dun sa 4 na fixture, yung waste niya ay dadaloy papunta sa horizontal fixture branch and papunta sa waste stack. So, ang hinahanap dito ay yung horizontal fixture branch, yung diameter niya, yung diameter ng waste stack, and diameter ng vent stack. So, bago natin makuha yung tatlong diameter na yun, hanapin muna natin yung katumbas na DFU ng bawat fixture natin. So, from the table 14.1, yung DFU ng bathtubs is 2 DFU per bathtub. So, multiply lang natin to. 2 bathtub times 2 DFU per bathtubs, cancel yung bathtub. So, we have 4 DFU. Next is sa water closet. So, makita naman natin dito, yung water closet naman natin ay merong 14 DFU. So, multiply ulit natin. 4 times 2 is equal to 8 DFU. Para naman sa lavatories, yung katumbas na DFU niya ay 1 DFU. So, multiply ulit natin. 2 times 1 is equal to 2. And lastly, sa kitchen sink, we have 2 DFU. So, 2 times 2 is equal to 4 DFU. So, add natin lahat yung apat na DFU na nakuha natin. So, 4 plus 8 plus 2 plus 4 is equal to 18 DFU. So, gamit yung 18 DFU na to, mahanap natin yung diameter ng horizontal fixture branch, waste stack, and vent stack. So, paano nga ba natin mahanap yun? Refer tayo sa table 14.2. So, makita natin dito, yung sa horizontal fixture branch natin ay horizontal fixture branch. So, sa third column siya. Hanap tayo ng mas malapit sa 18 DFU. So, we have 12 and 20. Mas malapit yung 20. So, ang katumbas na diameter niya is 3 inches. So, para sa horizontal fixture branch is we have 3 inches. Para naman sa waste stack natin is refer ulit tayo sa table 14.2, but this time sa fourth column na tayo, sa fourth column. So, hanap ulit tayo ng mas malapit sa 18. So, 10, 20, sa 20 naman tayo. Yung katumbas niya ay 2.5 inches. Ay, wait lang. So, 2.5 inches. Kung gagamitin natin ang ating imagination, yung horizontal natin papunta sa waste stack. So, parang malabong mangyari naman yun na mas malaki yung horizontal natin kaysa sa waste stack. So, kahit na mas malayo itong yung 48 na DFU, is ito yung gagamitin natin na diameter na 3 inches. Di baling same yung diameter ng horizontal at waste stack, hindi lang mas mababa yung yung waste stack natin kumpara sa horizontal. So, bale yung diameter ng ating waste stack is 3 inches. And lastly, para makuha natin yung yung vent stack, refer tayo sa table 14.4a. So, yung nakuha nga nating diameter ng waste stack natin is 3 inches. So, meron tayong ditong tatlong 3 inches at yung connected DFU niya is 10, 30, 60. So, yung ilan nga yung DFU natin? So, 18. Yung mas malapit sa 18 is yung 30. So, sa 30 na lang tayo kukuha. So, 30. Tapos, yung yung katumbas niya is 60. Tapos, sa taas ng pinakataas ng 60, yung sa required vent diameter is 2 inches. Kaya, yung vent, ang diameter pipe ng ating vent is 2 inches. So, that's all. Thank you.